In this video, I'm going to talk about average value of a function using integrals. This is one of the very nice applications of integrals. So basically, if we have a function f like this one here, if we have the graph of function f given like this, and if we are looking at the interval of x values from a to b, so f of a would be over here and f of b would be somewhere over here, f of b. So we want to find the average value of the function over this interval. So we want to be able to find the average value of function over the interval, which would be somewhere over here between f of a and f of b. And it is given by this formula. So average value I'm denoting by f bar. It is given by the formula 1 over b minus a times integral of f from a to b. Next, we will look at a couple of examples. The example says us to find the average value of the function f of x equals cosine x over this interval 0 to pi by 4. So let's quickly draw the graph of this function, cosine of x. Let's suppose 1 is somewhere over here. When x is 0, cosine of x would be 1. So the graph would start from here. And we know when x is pi by 2, cosine is 0. So let's suppose pi by 2 is over here. And the interval we are interested in is between 0 and pi by 4. So I'm going to put pi by 4 over there. So I can draw the graph of cosine function to be something like that. And on the other side, it goes like that. So we are looking at this interval from 0 to pi by 4. And we want to find the average value of the function between 0 and pi by 4 over the interval 0 to pi by 4. So for that, we simply need to apply this formula. F prime equals 1 over b minus a. A and b are the endpoints of the interval. A is 0, b is pi by 4. So we have 1 over pi by 4 minus 0. And then integral from a to b, integral from 0 to pi by 4 cosine x dx. So this will give us 1 over pi by 4. And we know integral of cosine x, the antiderivative of cosine x is simply sine x, as we have here in the formula. So this will be sine x, and we evaluate that from 0 to pi by 4. So this becomes, I can flip this denominator here and make that 4 by pi. And over here, sine of pi by 4 minus sine of 0. So we have 4 by pi times sine of pi by 4, we know is square root 2 over 2 using a unit circle or our calculator. And looks like this will simplify to, because we can cancel out this 4 by 2 to get 2. So this will give us 2 square root 2 over pi. This is the average value of the function over this interval 0 to pi by 4. And if you like, you can get an approximate value from calculator just to see where it would appear on the graph. So using our calculator, this comes out to be 0.90 when we round to 2 decimal places. So that means the average value of this function over the interval 0 to pi by 4. So we are just looking at y values from here to here. The average value is 0.90, which is somewhere over here. So this is where the average value is 0.90. Next, we have this example. Population of bacteria in a culture after T hours can be given by this formula. P at T equals 310 e to t. Find the average population of bacteria between 2 hours and 6 hours. Right, so let's first try to draw the graph of this function. So it's a nice increasing exponential function. And we know when t is 0, the population is 310. So we can, I'm going to say 310 is somewhere over here. And then it increases exponentially. So the graph is going to be something like that. So this is the graph of P of t equals 310 e to t. And we are looking at the average value of P, the population, over the interval 2 to 6. So let's say over this interval. So you see the y value at 2 is somewhere over here. So this is P at 2, and y value at 6 is somewhere over here. So we are looking at the average value of the function between these 2 points. So for that, we'll simply use the formula for average value. So average of P is 1 over B minus A. I'm going to write down the formula first. B minus A over integral of pt dt over the interval 0, well, 2 to 6. So let's plug in the values we have. B is 6 and A is 2 times the integral from 2 to 6 of 310 e to t dt. So 1 over 6 minus 2 is 1 over 4. And antiderivative of 310 e to t will simply be 310 e to t using this formula over here. And we evaluate this from 2 to 6. So this will come out to be 1/4 times 310 e to 6 minus e squared. And I can divide 310 by 4 to get 155 by 2. Then we are left with e to 6 minus e squared over here. So this is the average value. And again, you can use your calculator if you like to see where it would fall on the graph. So using our calculator, the approximate value for this one comes out to be, so approximately 30,693. So this is the approximate average value. So let's see where this value will lie on the graph of this function over here. When t is 2, this value over here will be 310 e squared. And that comes out to be approximately 2,291 rounded to nearest whole number. And when t is 6, we get 125,063. Over here. So between these two, the average value of the function is 30,693, which I assume will be somewhere over here. So this is where the average value of the function would lie over the interval 2, 6.